November 6th, variables on both sides. The goal is to solve for x. So this first example, we see there's a negative 4x on the left and a positive 3x here on the right. The goal is to either move x around so that all the x terms are on one side, like the left, or the right. It doesn't really matter which way you do it, so we'll show it both ways. Same problem. Here, on the left, we're going to add 4x to both sides. And you know that you have to add x to the other x term. You can't add 4x to 1, for example, or 4x to negative 62. So this gives us 1 is equal to 7x minus 62. Now we're looking at a two-step equation. We simply add 62 to both sides. We have 63 is equal to 7x. When we divide by 7, we get x equals 9. 9 times 7 is 63. On the right, what if instead we subtracted 3x? Will that still work? Let's try it. 1 minus 7x is equal to negative 62. And then we have to subtract 1. So we have negative 7x is equal to negative 63. And when we divide by negative 7, we get x is equal to 9. Same answer, but we had to divide by a negative. Generally, that's why I like to move the x to the side where x will stay positive. Let's look at some more examples. Here on the right, if I choose to add 5x to both sides, then I end up with 2 is equal to negative 108 plus 11x. My x coefficient came out positive. Then if I add 108 to both sides, I have 110 is equal to 11x. If I divide both sides by 11, x is equal to 10. Moving down, I will add x to both sides. That way I end up with a positive 6x minus 4 is equal to a negative 40. I'll add 4 to both sides. 6x is equal to negative 36. When I divide both sides by 6, x is equal to negative 6. Here's another one. I could add 5x or I could add 7x. The only way to get a positive value is if I add the bigger one. So I'm going to choose to add 7x first, and then I have 1 half plus 2x is equal to 41 halves. There's a couple different ways to deal with this fraction. I can subtract 1 half and go from there. Since they have the same denominator, that's not so bad. So minus 1 half minus 1 half. And this gives me, starting over here at the top, 2x is equal to 40 halves, which is another way of saying 2x is equal to 20. And then when I divide by 2, x is equal to 10. Sometimes the fractions won't be that easy to subtract, and there's another method. Such as, on the back here, if I wanted to cancel out this coefficient of 1/3 to get rid of all the fractions, I can simply multiply every single term by 3. So this becomes 15 plus 12x equals x minus 51. I avoid the fraction 1/3 by multiplying each term by 3. And then I solve it like normal. Subtract x from both sides. 15 is equal to 11x. 15 plus 11x is equal to negative 51. Subtract 15 from both sides. I have 11x is equal to negative 66. When I divide by 11, I get x is equal to negative 6. Let's look at one of these challenge problems down here at the bottom. Same idea, the fifths on bottom. So if I multiply every term by 5, I end up with 25x plus 2 is equal to 20x minus 23. I can subtract 20x from both sides, and I have 5x plus 2 is equal to negative 23. Then when I subtract 2 from both sides, I have 5x is equal to negative 25. And when I divide these both by 5, I get x equals negative 5.